This guy which you're looking at now, it's benzene. I'm going to show you as we keep going why I've brought benzene for you right now and what it's going to help you to know. So benzene is, what you must know is that for benzene, we're not going to do preparation reactions. And this is the reason we're not going to learn about how to make benzene. Of course, there are other ways that you can use to make benzene, but it's not important because benzene is found naturally. Okay. So benzene is a naturally occurring compound. Here's the reason. That's what I'm saying. That's what I'm underlining now. Benzene is a naturally occurring compound. In other words, you can find it in nature. You don't have to prepare it in a lab. So it's not so important for us to be looking at the reactions that we do to produce it, because it's not that important. Because we find it in crude oil. When we mine crude oil, you can find benzene, okay? So it's found in crude oil. Of course, gasoline is part of crude oil, so you can find it in gasoline. You can find another thing. So the other things, that's what I'm talking about, like gas, cigarette smoke, and then it is also emitted by volcanoes and fires and forest fires. All these emit benzene. So benzene, we can find it naturally. Okay, after some, of course, these are like events that happen not as much as mining of crude oil, but like volcanoes and forest fires do happen, and you can use that to get benzene. So benzene, okay. What about the reactions in which that benzene itself does? If you go through your slides, you're going to see that it's not many that you gotta know. You have to. There's only one in there, but I'm gonna show you the second one, which also comes in past exam papers. You find it in the 2024 paper as well. So let's see. Not this one. The first one is not the one, but here is the reaction, is when you add, is the addition reaction that happens. Okay, it's a substitution reaction that happens, not an addition, but a substitution reaction that happens. Okay, it react with, it's the reaction between benzene and bromine. So benzene and bromine, it's a substitution reaction, please. Okay, benzene and bromine. So this is a substitution reaction. Okay, and it's not an addition reaction, it's a substitution, because one hydrogen is going to go. Benzene's double bonds are not touched because it's not really double bond. It's like, yeah, I mean, when you see the structure, it looks like double bond, but they throw their electrons together, the pi, so, and they make a structure which is more like just a double bond. So you can't go to a double bond and break it. So because of that, our benzene ring is not touched. It's so stable. But what happens is one of the hydrogens can go. So here we have a benzene like this. Okay. And if I come and I add bromine in the presence of, so if I add bromine in the presence of FeBr3, then a reaction is going to take place. And that reaction is bromine is going to substitute a hydrogen. Because what you must know is that there is a hydrogen, a single hydrogen on each of these positions. There is a single hydrogen. There are 6 hydrogens in this benzene structure, 6 carbons and 6 hydrogens. Okay, so one of the hydrogens will go, and then you're going to have bromine go there. So it's going to be like, we have the same structure. Our structure is not going to be affected, please, but one of the hydrogens will now become a bromine. That is what happens to the benzene ring, okay? When you add, look, this is FeBr3. Don't confuse it with the PBr3 that we did when we were adding to alcohols. It's not. For alcohols, we had PBr3, PCl3. It was a phosphorus, which is not even related to Fe. Fe is a phosphorus is in like group 5 or group 15, right? Phosphorus is that's phosphorus. This is iron Fe, and it is a transition metal. They're not even related, so don't confuse this. FeBr3 is what we add with bromine, okay, when you want to break and when you want to add to your benzene ring, right? When you want to do a substitution reaction, rather. Now the other reaction which happens, very nice, so another substitution reaction again is, so here, if I want, I can say the C6H6 plus, I can put the things, I can just put an arrow to say, you can say plus Br2 and put FeBr3 on the arrow, it's still fine, okay? Or you can put them both like this. What you're going to have is C2H5Br, okay? It's one of the hydrogens that are substituted. I know you can master this. The second reaction that happens for this guy, it is when we are having somebody very nice, and that is an AlCl3. So what is it that's going to be? Look at it. You have a benzene, and this is the production of something very important, and that guy is toluene. I'm sure you remember toluene. What did we say? You'll be having this. Here's your benzene ring, and I'm going to come and put, we can add something like a maybe CH3Cl, okay? Or we can even add, I'm gonna show you somebody called acetyl chloride, which is going to be CH3, then COCl, okay? You know what this guy is like? It's like it's a carbon bonded to a carbon, then this carbon is a double bond to a chlorine. That is why you see it having only two things, CO and CO, because this CO carbon should have, we know, three things and then the bond with the other carbon. But here it has two things, because this is a double bond with O, then a Cl. So you can say it's like this, double bond to O, then here is Ce, then here there are the three. This is called acetyl chloride, okay? And here we have our chloromethane. Here we have it. Okay, so what are we going to have? If I have these two guys, whatever I have, something with a chlorine somewhere, okay, he has a chlorine somewhere, and I bring and I put AlCl3, okay, AlCl3. I can do the same here, okay, can come and put an arrow, then I would say I'm going to put AlCl3, right, this, right? I mean, AlCl3 is just aluminum trichloride, right? So what you should know is that whenever you have something with a chlorine, right, like this, it has to have some carbon and hydrogens, right, and a chlorine somewhere. If you put AlCl3 and add it to the benzene ring, it's going to attach itself to the benzene ring, because you know what's going to happen is that this Cl here is going to be removed by this thing. So AlCl3 has a special thing. It removes a hydrogen and the Cl from whatever has a Cl, it removes it, okay? This AlCl3, yes, it removes another Cl and the hydrogen. And then this remaining thing just gets stuck there. So what you end up having is you end up having toluene, okay? This is how we make toluene. So you end up having toluene, which is methyl benzene, okay? You just have benzene and a CH3. This is your toluene. Okay, we call it toluene. This is our methyl benzene. Don't forget it. Don't forget toluene. Don't forget aniline as well, you know. And don't forget your benzoic acid. So here you have we'll talk about it, the benzoic acid. Here's toluene. And what am I going to have here? What am I going to have? This is not going to be toluene this time though. Okay, for here we can make toluene. But for this time now, we are going to have, yes, Cl goes, yes, and H goes. Then this remaining thing just goes and sticks itself. So it's going to be like this. It's going to be like this, right? And what am I going to have? CH3CO, okay? The O comes and it attaches itself. Look, so we have it, no, or the C comes and attaches itself, sorry. So it's going to be CO, then CH3, if you want to put it like that, okay? That's what happens. The carbon with the O is the one that attaches itself, okay? And that is what happens because the chlorine from that guy goes and you'll be having it. So this is what, it's not toluene this time though. And if you actually see what this look like, here we call this an acetophenone. Okay, it's like a ketone, right? It's a ketone. Here, this is acetyl chloride and we have our benzene, okay? Acetyl chloride, right? We have acetyl chloride. Then here we can call this aluminium chloride or aluminium trichloride, whatever. So this is aluminium chloride, okay? So easy. So here, this is just, we know that it will be a carbon to a bonded with a double bond, then it is bonded to a carbon with hydrogens, then here is your benzene ring, right? Because what happens is we remove the chlorine there and we put that guy. So that's how simple it is. What must you remember? What must you remember the reactions of benzene? First, you'll be putting bromine, and then the other one, it is when you are adding a methyl or something else. Okay, you want to put something else, but that something had a chlorine. It had a chlorine. And what do? You put your aluminium chloride here, and what does it do? That aluminium removes the chlorine and the hydrogen, and that something will stick. So that is how we make toluene, which is very important. This is an important one which I want you to remember. It's actually the most important one right now, the production of toluene, okay? Although they can ask this other one as well. It can be asked. What you just know is the chlorine will go and here the hydrogen will go. Then this remaining thing will stick itself there. That's just what happens. That's how easy it is. And you'll be done with benzene. I know it's hard. It's not hard, I mean. Okay? That is it. Let's go on to the next thing. Goodbye for now.